abundance. So of note, abundance is typically highest near groundwater inputs and decreases with distance away from groundwater influence. These animals utilize various submerged cover objects as refugia from predators. This includes rocks, leaf litter, woody debris, vegetation. They utilize interstitial spaces and rocky and gravel substrate. And abundance is negatively correlated with siltation because it fills in those important interstitial spaces. They occur in relatively shallow flowing water and do not typically occur in deep water that is suitable for predatory fish because predatory fish limit their downstream distribution. So our focal species are Salado salamanders. We have the same map up from Devitt et al. And you can see that these are the northernmost of the central Texas Eurystia species. They occur in approximately 11 locations in 7 federal critical habitat units, although I note that a couple of new localities have been discovered in the past year or two. And our focal site is Twin Springs, which you see circled in the right panel as federal critical habitat unit number 9. Twin Springs is an approximately 170-acre preserve for endangered and threatened karst invertebrates, golden cheek warblers, and Salado salamanders. And here you can see the outline of this preserve in relation to the city of Georgetown. The preserve is primarily surrounded by moderate to low density housing. It has minimal anthropogenic impacts compared to other sites in the northern segment of the Edwards Aquifer. And in a study conducted by Diaz et al. In 2020, Twin Springs had the lowest recorded contaminants in the water and also the lowest recorded contaminants in salamander tissues out of any of the study sites that were included in the northern segment of the Edwards Aquifer. This site also has the longest continually surveyed population of Salado salamanders. So routine monitoring began in 2009 with Ben Pierce and his students at Southwestern University. These were continued by Dr. Pierce and Cambrian Environmental up to the present. And for the first about 11 years of monitoring up until the start of this project, these were conducted on a monthly basis. But in spite of the low impacts and site protection, salamander relative abundance has declined at this site over time. So in the first 3 years of surveys, 2009 to 2011, there was an average of 23.9 salamanders detected per survey. And in the 3 years immediately preceding this study, we were down to 5.7 salamanders per survey. And it's also worth noting that this isn't the only long-term monitoring site that we have for salamanders in Williamson County. There are 8 others, and out of the 9, this is the only one where we had a documented decline in salamander populations. So if the site occurs in a preserve and it has minimal anthropogenic impacts, low contaminants, why would this population be declining? And our best estimation is that this is a cascading set of habitat degradation issues in both the riparian habitat and also the spring habitat. So the riparian areas were overgrown with dense ash juniper. This caused a thick layer of duff in the understory, little sunlight to the herbaceous stratum, and these combined to cause sparse riparian herbaceous component. And without that riparian herbaceous filter, then you get sediment runoff and siltation of the spring run. In addition, we had fallen trees into the spring run that were causing dammed areas. This spring occurs in a fairly incised and narrow draw, which is prone to flash floods. So this created scour pools within the habitat as well. So these dammed areas and scour pools, that deeper area provided habitat for predatory fish to move in. So here I'll show a series of photos starting at the spring outlet and moving downstream of the spring run so you can see what this site looked like prior to restoration. So here we are at the spring outlet looking upstream, spring outlet looking downstream. Here's about 10 meters downstream of the outlet. You can see here that the spring habitat itself still looks like it's in fairly good shape. It's a narrow run, shallow, lots of rocky substrate, but the riparian areas around it are pretty much void of herbaceous material and have this thick and dense deadfall and trees and shrubs. Here are about 15 meters downstream. This is an important area to highlight. This is about 20 to 30 meters downstream of the outlet. And here you can see a deep pool caused by trees falling over the spring at about 30 meters downstream. And this area is of particular importance because when Ben Pierce first started the work, he said that this area had the second highest density of salamanders at the site. So again, here you can see the choke point and trees causing that area to dam up. Once we move past that tree fall, again, the spring habitat itself looks fairly decent, but the riparian areas don't have a lot of vegetation in them. So our overall goal with this work was to increase and improve salamander habitat through a series of events, including canopy reduction, dam and debris removal, riparian stabilization and erosion control. We wanted to improve the flow in the creek channel, remove silt, and also reduce the impacts from flash floods. We maintained salamander monitoring throughout the restoration process, but at the start of this work, we moved to a robust design scheme to allow estimates of detection probability and also true abundance. We conducted these surveys on a quarterly event. So 4 times per year, we had a quarterly survey, and each one of those survey events had 4 secondary surveys. We monitored in a capture-recapture framework where we identified recaptures with the head patterns. And during every survey, we exhaustively surveyed the upper 50 meters of the spring run using visual encounter surveys. And we also had trap stations every 10 meters. We additionally performed vegetation surveys in the riparian areas to track any changes associated with our restoration efforts. This included 4 transects that ran parallel to the spring run. We had quadrat stations every 10 meters along the transect. And at every station, we had a randomized quadrat location where we measured canopy, shrub, and ground cover composition. We performed these vegetation surveys once per quarterly event. We also performed similar quadrat surveys to track changes to the spring habitat. Again, these were conducted once per quarterly event. We conducted the spring monitoring as the first thing we did in each survey. So before any salamander surveys where we got in and we disturbed the cover objects. We performed 2 randomly located quadrats per 10-meter creek segment. And in each one of those quadrats, we measured cover object composition, substrate composition and depth, water depth, and also flow habitat. And if you're not familiar with these flow habitat categories, these are qualitative groupings that are meant to capture the combination of water depth and flow velocity. So starting at with a pool, that would be deep water with very little flow. Moving up to riffles is shallow water with higher velocity flow. And in relation to salamanders, we would consider pools to be the worst salamander habitat and riffles to be the more appropriate salamander habitat. And I don't want to belabor the point, but I think it'd be useful to show a little schematic of our monitoring and restoration area. So the blue line represents the spring run. You'll see I've marked every 10 meters. So at each one of those 10-meter marks, we had a trap station for salamanders. Between each of those 10-meter marks, we performed 2 spring quadrat surveys per quarter. And then you'll see 4 parallel vegetation transects, each with 6 stations. We performed a veg quadrat at each one of those stations per quarterly event. And the restoration boundary itself is outlined, which is the upper 50 meters of the spring run and 25 meters of riparian area on either side of the spring run. We conducted about a year of pre-restoration salamander and habitat monitoring prior to beginning the restoration work. And then we started in October 2021 with a primary timber clearing event. And here we removed all deadfall trees that were less than 4 inches in diameter at breast height, shrubs, vines, and also some targeted lower limbs within that 50 by 50 meter area. We also removed all timber and debris in and within 5 meters of the spring run, including all those trees that had fallen over and into the spring. In May of 2022, we had a native seed application for both upland and riparian seed. And then in February 2023, we had a secondary and unintended clearing event because in February 2023, we had a pretty significant freeze that fell some extra trees and limbs in the area. So we cleaned those up as well. We also made physical alterations to the spring run channel. And this is a good time to mention that Twin Springs has a very low spring discharge. So when most people think Texas Springs, they're probably thinking of something like Barton or San Marcos Springs, but Twin Springs isn't anywhere close to the level of discharge of those areas. This site averages about 0.5 liter of flow per second. And with that low flow, that presents some challenges. So the less flow means less ability to flush silt out of the system. So we physically altered the spring run to create a narrow, shallow, and swift flowing spring throughout the upper 50 meters. And we did this by removing rock dams and choke points. And then we regraded the channel bed for a continuous elevation drop. And those two tasks were conducted with hand tools. So that's swinging pickaxes and having shovels in the spring. We also placed boulders in the wider areas to narrow up the spring run to increase velocity. And then what ended up being surprisingly effective is that we just used hand brooms to sweep the silt downstream and out of the restoration area. We performed all of this work with hand tools, one for cost efficiency, but also just the topography of the site itself makes it difficult to get heavy machinery down to the creek channel. We performed spring run alterations from July 2022 to July 2023. And we performed these after the last salamander survey in each quarterly event. So on the last day of salamander surveys, we would exhaustively survey the spring channel, capture all the salamanders, hold those salamanders out of the spring run while we made physical alterations to the spring, and then replace all the cover objects and salamanders at the end of it. And this allowed us to, this iterative approach to restoration not only was time and budget efficient, but it also allowed us to evaluate progress. So between these alteration events, these physical modifications, we allowed the dust to settle in the intervening months before we came back for the next quarterly monitoring period. We also installed a small gabion approximately 10 meters upstream of the spring outlet. So the intention of this was to slow the flash floods to prevent scouring and to also collect debris from washing into the spring channel. And I'll note that the intention here is not to impound water behind the gabion. So before I show and discuss the results, it's worth noting that habitat restoration does not yield immediate results, and the system has to have time to respond to the restoration activities. But with that in mind, the current results are very encouraging. So again, this is a series of photos starting at the spring outlet and moving downstream to the 50-meter endpoint. And throughout this, you can see riparian herbaceous recovery. You can see a lack of pools in the spring run, shallow rocky substrate throughout, all the way down to the 50-meter mark. And then to hammer this home a little bit more, here's a series of photos that show before and after at the same photo locations. So you can see in the uplands here a recovery of the riparian vegetation, the same in this photo. Here is the spring outlet before and after, about 10 meters downstream of the spring outlet. And then of most importance for this study, here is that deep pooled segment after restoration. So the photos do a great job of telling the story, but also we can demonstrate that we see a response in the measured variables as well. So I'll ask you to please forgive us for the rather simple plots and comparisons, but we're less than 2 months removed from data collection. So this is what we have so far. These are box plots of each of the riparian habitat components that we measured. Time is on the x-axis and percent cover is on the y-axis. And the patterns can kind of be hard to discern, so I'll walk through these comparisons. First, we compared canopy cover before and after the initial timber clearing event, and you'll see that percent canopy cover was significantly lower following this effort. Correspondingly, percent leaf litter ground cover was also significantly lower following timber clearing. Percent bare soil reacted a little bit different. We observed an increase in bare ground in the year following timber clearing, but this reduced back to near pre-clearing levels as the herbaceous plants recovered in the last year of the study. And ultimately, our goal here was to recover the herbaceous layer to help prevent siltation from runoff. And you can see that percent herbaceous cover significantly increased from the first 2 years to the last year of the study. And these are similar box plots for the spring quadrat measures. And here I'll compare the spring habitat conditions prior to physical alterations of the spring run. So this is the onset of monitoring to July 2022. And we'll compare those to after the physical alterations were complete. So the 2 events after July 2023. We did not see a difference in the percentage of bedrock substrate, but we do see a significant increase in the percent cover of gravel substrate, and most importantly, a significant decrease in the percent cover of silt. And accordingly, our restoration efforts significantly decreased substrate depth because for the most part, the substrate was silt in the system prior to restoration. And we also see a significant decrease in water depth. This figure shows the change in flow habitat over the course of the project, which again is a categorical reflection of water depth and flow velocity. The 4 flow habitat types are color-coded and the number of each type per survey event are plotted. And you can see that the number of undesirable pools and glides in the spring run decreased and the more suitable areas of runs and riffle segments increased as we conducted the restoration work. And we also have evidence that our gabion was working as intended. And because here you can see a pile of debris on the upstream side of the gabion that was deposited during a small flood event in January of this year. So the gabion worked to keep that material out of the restored creek channel. Here we're showing the demographic estimates from our capture mark recapture modeling efforts. The best fit model included random temporary immigration and time varying survival and detection probability. So again, you see time on the x-axis and the estimated parameter on the y-axis. You can see that we have pretty large confidence bounds on these survival probabilities due to low captures. Detection probability and estimated abundance, the 2 lower panels, appear to be fluctuating seasonally. But at this point, there's no apparent pattern in any of these estimates associated with restoration efforts. But again, active restoration occurred up until the last 2 events of the project. So we don't expect to see a signal in the salamander demographic data just yet. And we'll have to conduct future monitoring to determine if the population responds to that work. However, we do see some changes in salamander distribution within the spring run that is the result of the restoration work. So here we're showing the capture results from each of the 12 survey periods. Each dot represents a salamander capture, and the y-axis shows distance as measured from the spring outlet that each salamander was captured. And what you'll notice is that we began capturing salamanders at the downstream restoration limits as we started the restoration efforts. And also salamanders began to populate the former deep pooled areas as we improved habitat. So again, habitat restoration techniques for Central Texas Eurythia are still developing. We're only aware of 2 or 3 other projects that are attempting this type of work, and none of them are published to date. But we can use the published ecological research as a roadmap to give us habitat goals and give us an idea of how we want this habitat to look in the end stages. So here we demonstrated the ability to improve salamander habitat through restoration of riparian areas and also physical alterations to the spring run. And while our habitat metrics demonstrated immediate improvement, additional monitoring is needed to determine if the salamander population responds accordingly. Additionally, Active stewardship of the site is necessary to maintain the restoration results and continue recovery. This work was primarily funded by a Section 6 grant issued to the WCCF from Texas Parks and Wildlife and U.S. Fish and Wildlife. We appreciate both agencies for facilitating this work. We'd like to thank Ben Pierce and his students and Ashley Wall for collectively conducting the first 9 years of salamander monitoring at Twin Springs, and also thank Williamson County staff and volunteers who assisted in timber clearing. And I'd be happy to take any questions.
Excellent. Thank you, Zach. Andrew's been doing a diligent job answering some of the questions in the chat. And I can, there's quite a few in there, so I'll address some of the ones he hasn't gone to. So the contaminant one got answered. Or do you guys, Andrew posted the link to the paper in the chat. Do you know what kinds of contaminants were tested for in that study you mentioned by Pete Diaz?
I know that there was a series of hydrocarbons, but I don't remember everything.
Yeah, okay.
And wastewater components as well. I do remember that at Twin Springs, there were the only contaminants that were documented were a couple of wastewater contaminants.
Okay, very good. Yeah, and Andrew was kind enough to post the link to the paper in the chat for those interested in the details. Somebody else asked that they hear a great deal about ash juniper overgrowth beyond historical bounds in the Texas Hill Country. Should there be as much ash juniper trees in the salamander habitat? I think has there been an overgrowth of ash juniper in these riparian areas too?
Well, I think the overgrowth of the ash juniper was clearly one of the big problems at this site. And I know that's a conflicting agenda with overlapping golden cheek warbler habitat. But in this case, the reduction of ash juniper canopy really allowed the herbaceous component to come back pretty quickly. And we'll note that really we saw a significant decrease in canopy, but that the percentage wasn't a huge decrease. So it's, I don't know how much reduction will tick the golden cheek warblers off, but we would seem to think that there's still plenty of canopy to keep them happy there.
Yeah, I would also add, if I could, that the question, whether the ash juniper are historical in this area, I would think that they are, given the presence of golden cheek warblers and the structure of the remainder of the preserve.
Excellent, thank you. I see he's answered the question about the software, about Wild ID. Okay, here's another question here. Did the placement of boulders on the banks affect the filtration of the plants? I guess perhaps like water moving through the soil, did it adjust the sort of flow paths, I guess, of the water moving from the uplands?
No, we only placed boulders in areas where the banks were undercut. So we didn't place boulders along the edge that would impact how water is running into the creek channel. The only place where where I guess that would be applicable is kind of what you see here in this last photo. You can see we put some big boulders on the edge to narrow up what used to be that wide pool. But for the most part, boulder placement was intended to narrow up the spring run and to also get them into the undercut banks to prevent those banks from crumbling into the creek channel.
Dumping a bunch more sediment in, right? Mm-hmm. There's a question here about stream temperatures and shading.
Yeah, that's so we've talked about this work a little bit, and that's the question that always comes up. Everyone's concerned about, is the removal of canopy causing the water temperature to increase? And it's not. I mean, even at a low flow site like this, there's enough constant flow through the system that there's no difference. There's no significant increase in water temperature, even 50 meters downstream of the spring outlet.
That's great. Thank you. Okay, somebody asked a question here. What is the take-home message for Texas master naturalists to communicate to the public about threatened and endangered species? I guess interpreting that a little bit, maybe to mean in the context of this project, Zach, is there any kind of maybe simple message that people that advocate for threatened and endangered species you'd really like to drill home for them?
Well, I think, with the concern with this site and the system in general, and the reason why we felt that this work was necessary, is that there's not a lot of known Salado salamander locations on the planet. And that is similar for several other of the Central Texas Eurystia salamanders. So at that point, you are putting a lot of your eggs in one basket. And so anything we can do to improve habitat is useful for these sites and for the species in general.
Excellent, thank you. Okay, how many pools were present during the years when salamander populations were larger? It seems logical that salamanders prefer riffles, but I'm wondering to what extent the pools would have occurred naturally.
I don't know exactly. I do know that the pool that you see on the screen right now in the left panel, that that occurred over the course of monitoring. So from what I understand from communication with Dr. Pierce, is when he first started out there in 2009, that area did not look like the pool that you see in the left panel of that slide. So that occurred through scouring and damming of the spring run. And these pools do occur naturally in spring runs, and they do get populated by predatory fish naturally as well. But again, when we're talking about 7 critical habitat units and 11 locations where these exist, then it's worth going in and improving the habitat to the best of our ability, because we do know that the presence of fish pretty decidedly limit the distribution of salamanders. So once you get to an area that has predatory fish, salamanders are not going to occur past that unless you have a secondary groundwater input that occurs past that pool. And that's another neat thing to note, to document about this, is that as we improved the habitat, as we lowered the water levels, and as we got rid of these thick layers of silt, we uncovered groundwater outlets that had been hidden to us for the last 5 or 6 years. So we have new groundwater outlets that are visible further downstream, and those additional groundwater outlets extend habitat and extend the ability for these salamanders to distribute downstream.
That's great, thank you. It's a kind of a comment here about algal build up in the summer as flow decreases. Is that anything you've observed or are concerned about?
Well, you can see it's pretty. The photo that's up right now is pretty scuzzy. That pool would have a pretty significant algal blooms really through quite a bit of the year, and we're hoping that since we have increased the flow velocity through that, it'll help flush that out.
Another question here: are there any partner needs for projects like this? Not 100% certain if that means is there any partnerships that are possible? Like, could you guys use help? Is there resources that partners could contribute to build on this, or interested in doing more sites, that kind of thing?
Sure. I mean, I think there's always the need for cooperation. One, we have to have people capable of coming up with an idea of how to restore the spring run. So kind of the best design from what it looks like today. You have to have crews of people who are out there actually doing the physical work and the chainsaw work and the seeding, and then part of that as well is especially with our group, and we're primarily a group of herpetologists. So we could always use some advice on the best way to native seed and what plants we should be targeting in these areas.
Did you have a slide with your contact info at any point, Zach?
I don't, but I can provide that for it to be emailed out to the group.
That'd be great. Maybe Andrew could post his and yours in the chat or something if you
Sure.
folks want to get in touch with you guys to offer, support or collaborations moving forward. Okay, another comment and question here. Great job on the habitat restoration. Any idea on the frequency, time, and effort that will be required to maintain the habitat?
Yeah, that's a great question. That's the big unknown, because as I mentioned, even during the course of this work, we had a second freeze event that dropped trees and limbs in the restoration area and kind of, it didn't undo what we had done, but it kind of made a mess of what we had already done. So those things are just going to happen. And, at this point, we conduct a fair bit of salamander monitoring. And over the course of about a decade of performing that monitoring and now also performing some habitat restoration work, I think that we've collectively kind of come to the idea that that habitat maintenance and stewardship should be part of routine monitoring. So if we already have a crew on site that's monitoring for salamanders, then we might as well perform some of these smaller tasks that we can to keep the habitat in good shape while we're there. Because there's a lot of little things that we can do when we're on site, and if you ignore those, they pile up pretty quickly, and then you end up with the large dams and stuff like that again.
There's another question or comment about the sustainability of the restoration work. There's a question that says, will it return to the way it was in 10 years? And would controlled burns or prescribed fire help keep the habitat and the junipers in check?
Prescribed fire would be great, but it's also surrounded by neighborhoods. So, even if they're low to moderate density, that becomes a conflict of interest there. But at this point, I think there's no way to entirely know what it's going to look like in 10 years. I think we've applied what we saw happen over the last 10 years to try to do the best we can at this site for what we were given and the amount of time that we were given. But we're always, one freeze or one giant flash flood away from seeing how well the site actually responds.
That's good stuff.
And again, that's just part of it. This, as I mentioned, the habitat restoration for these animals is really in its infancy. So we're figuring this out as we go.
Yeah, that's a great point. Did you consider taking water quality monitoring of the spring itself to include with salamander habitat?
What type of water quality monitoring? Or was that part of the question?
Yeah, that they didn't specify. So I know you said you took flow. Was there any other like pH, conductivity, all that stuff you may?
Yeah, we took per quarterly event, we take kind of the standard water conditions, temperature, pH, conductivity, dissolved oxygen, and then also flow discharge. But we didn't do anything beyond that.
Another question here. What are the core reasons at the site for bank erosion? Of course, Texas has always had flash floods, but is the primary causality anthropogenic regarding bank erosion in this case?
No, I don't think it was anthropogenic here. I think it was just a lack of any sort of riparian or herbaceous stratum. That coupled with flash floods just kind of disintegrated the creek channel edges.
Excellent. There's a follow-up comment here from an earlier statement about the what should be the take-home message, and somebody posted a good rule of thumb for the public as a take-home message is don't put contaminants down the drain and plant native plants. There we go. Comment here, it's awesome to see habitat restoration projects focused on herps. Applaud their efforts for TPWD and Fish and Wildlife Service funding. Look forward to hearing about how the population responds at this location. And then one more comment here. It's helpful to mention that this site is part of an adaptive management this is Josh. It's helpful to mention that this site is part of an adaptive management process with the Williamson County Conservation Foundation and will benefit from more continual management than other sites potentially. So good stuff. Thanks for that, Josh. So we still have more time if there's any more questions or comments people want to post. Just, my own comment and thought about the juniper situation. Somebody asked about the historical, abundance of juniper now, or historical abundance relative to now. It seems like there's a general pattern that in the absence of fire and all these other processes that occur at a larger spatial scale, there is a bit more juniper on the ground now than used to be, right? So I think that fits with the patterns in other areas. If the juniper's grown up, crowded out the herbaceous layer, that all seems to make sense in terms of the erosion and other things that are happening. You may have mentioned this. Are there other sites and or springs you would like to include and do this kind of work at?
There's probably, my guess is that we could show up to pretty much every salamander occupied spring in Central Texas and be able to come up with some way to improve it. Some of those could use quite a bit of improvement because some of them occur, in the middle of downtown urban areas, and some of them may not require a lot of improvement. But in general, some sort of restoration could be done at just about all of them. And we have our fingers in another project right now, and as I mentioned, we're aware of maybe one or two others that are going on. But again, this is kind of a collective learning experience where we're improving habitat based on our knowledge of the ecological needs of these animals, and not so much on any sort of playbook that tells us how to restore them.
Yeah, that's great. Thanks. So here's a kind of a comment and a question. It appears that you positioned mature riparian plants in your photos. What is the status of the riparian plant seeds that you put out?
We did not plant any mature plants. Every bit of the riparian herbaceous material that you see came back after canopy clearing. So that was either part of the native seed bank that was there, and it was just allowed to sprout once it didn't have dense canopy over the top of it, or it potentially came from the riparian seed mix that we put down. That's confounded. We don't know which one it is, but we did not plant any mature plants. Everything was either native seed bank or the seed we put down. And I'll also note that this occurred during 2 years that were pretty poor for herbaceous growth, because we had a pretty rough drought in the summers of 2022 and 2023. And in spite of that, we still saw a decent amount of herbaceous recovery.
Excellent. Just a testament to what you can do when the conditions come together, right? Okay, great work on the project and reporting. Most likely these projects are going to be more needed due to the amount of urban sprawl and other man-made changes to the natural state. Yeah, probably quite likely. Wonderful presentation, thank you. Another question here. Did you say there was an upland seeding planting in addition to the riparian area? And if so, was that to reduce sediment in the stream? Was it successful?
Yeah, so I've kind of collectively referred to the whole area as riparian because it's in pretty close proximity to the spring run, within 25 meters. But we do have a pretty distinct area that is closer to the water, as you see in the photo here. And then you can kind of see that there's fairly steep banks that move up into the remaining, 15 or 20 meters or so of the restoration area. And because that was more upland, we put upland seed mix in those spots.
That's great. Another question here. Do you think there could be a number of springs with salamanders that are unknown to TPWD? And I'll add Fish and Wildlife Service in there, due to their presence on private lands. Landowners may have no idea their property is special, or they do, and they're afraid of regulators coming in.
I could not have said that better. There are, for sure, undocumented populations on private property, and undocumented for various reasons.
Excellent. Well, there are no further questions that I can see right now. So if nothing comes in the next couple of seconds, Zach, thank you very much for your time. It's a great presentation, awesome work. Really excited to see this kind of thing happening, and we'll keep an eye on this. Oh, one more question came in. What is the cost for consultation on improving habitat? My guess is they should probably email you for that specific, right?
Yeah, probably so, because that'd be pretty site specific.
Yeah. Somebody else comments, and can potential sites be detected by remote monitoring? I think that's probably possible to look for springs using aerial imagery and whatnot.
Yeah, I imagine so. You can identify areas where you can suspect the springs are, but again, if you look back at the aerial image of this site, you certainly cannot see a spring outlet or water or anything like that. So a lot of these are going to be, you can document these kind of like incised finger canyons where you suspect a spring may be coming out somewhere. But a lot of these smaller springs, you're not going to be able to see from aerial imagery.
Okay, awesome. Well, I think that is it in terms of the questions. So Zach, again, thank you very much for your time. Before I let everybody else go, I'm just going to share a quick slide here.